In this class, now I am going to explain you the complete concept of three-dimensional coordinate geometry and direction cosines and direction ratios of a straight line. 3D coordinate geometry and direction cosines, direction ratios of a straight line. See students, first let us know the meaning of a space. How do you define a space? Space means the region which surrounds to us. In this space, now I would like to consider three mutually perpendicular real number lines like this. What are these three? Three mutually perpendicular real number lines. 1, 2, 3. If you take any two of these three, angle between those two lines is equal to 90 degrees. This real number line is said to be x-axis. This real number line is said to be y-axis. This real number line is said to be z-axis. These three are concurrent at one point. That point of concurrency is known as origin, which is denoted by the letter O. This complete system is known as 3D rectangular coordinate system. You know, 2D coordinate system, 2D rectangular coordinate system. But here one axis is extra, no z-axis. Hence, this system is said to be 3D rectangular coordinate system. When you go to the higher education, like graduation, post graduation, there we call this system as R cube space, because your x-axis, y-axis, z-axis, three are real number lines. Then R into R into R cube space. Okay students? Right. You know, this is x-axis. You know, in this system, right side portion of origin on the x-axis is positive. Left side portion on the x-axis is negative. So in the same manner, whereas on the y-axis this part is positive, this part is negative. So go to the z-axis. So upside portion is positive, below the portion, below of origin is negative. So hereafter, now here we need to know about three planes. One is passes through x-axis and y-axis like this. The plane which contains x-axis and y-axis is known as XOY plane, because origin is also part of that plane. Hence, that plane is said to be XOY plane, or you can say it as XY plane. Similarly, send a plane through y-axis and z-axis like this. The plane which passes through y-axis and z-axis is known as YOZ plane, because origin is also part of that. YOZ plane, or you can say it as YZ plane. Similarly, send a plane through x-axis and z-axis like this. The plane which passes through x-axis and the z-axis is known as ZOX plane or XOZ plane. ZOX plane, or simply you can say it as ZX plane. I think you have got the meaning of XY plane, YZ plane, ZX plane. Origin is part of all these three planes. Hereafter, let us learn the meaning of x coordinate, y coordinate, z coordinate of a point which is located in the space. In the space, there is a one point P. To coordinate that point P, here we require three real numbers. Let us say that three real numbers as x comma y comma z. I have taken a point in the space and I would like to coordinate that point with respect to this x, y, z axis. So what will be the coordinates of that point P? X comma y comma z. So here we have three axes, hence we get three coordinates. In the 2D coordinate geometry, there you have written p x comma y. You know there the meaning of x coordinate of a point. The perpendicular distance from, see, you have defined like this. This is 2D coordinate system. Here you have taken a point P x comma y. How did you define x coordinate of this point P? The perpendicular distance from P to y axis is known as x coordinate of this point, and perpendicular distance from P to the x axis is known as y coordinate of that point. In the same manner, in the 3D coordinate geometry, so what is the definition of x coordinate of a point which is located in the space? See the definition, very easy. So the perpendicular distance from that point to the yz plane. So this is y x axis and this is z axis. This plane is there, no? What it is? YZ plane. YZ plane. Now point is there here. Now draw the perpendicular distance from this point to this YZ plane. So that is said to be x coordinate. Okay? What is the x coordinate of a point? The perpendicular distance from that point to the YZ plane is known as x coordinate of P. Similarly, can you define y coordinate of this point? The perpendicular distance from that point to the zx plane. So this is x axis, this is a z axis. This plane is there, na? This is called zyx plane. Point is there. Now drop the perpendicular. Drop the perpendicular. So this length is equal to this length on the y axis. What is the y coordinate of this point P? Perpendicular distance from that point to the zx plane. This length, this length. So that is equal to this length on the y axis. Hence, this length will be called y coordinate of that point. In the same manner, can you define z coordinate of this point? Tell me, what is the z coordinate of the point which is located in the space? The perpendicular distance from that point to the xy plane. Where is xy plane? This is x axis, this is y axis. This is xy plane. Now drop a perpendicular on the xy plane. From this point to drop a perpendicular on xy plane. So this length is called z coordinate of that point. That is equal to, this length is equal to this length on the z axis. Hence, the z coordinate of this point is perpendicular distance from that point to the zx plane. Okay, student, sorry. Perpendicular distance from that point to the, this is x axis and y axis, no, xy plane. I think, I hope you have understood the x coordinate, y coordinate, z coordinate of a point which is located in the space. Can you define x coordinate of the point? The perpendicular distance from that point to the yz plane is known as x coordinate. Perpendicular distance from that point to the zx plane is known as y coordinate. Perpendicular distance from that point to the xy plane is known as z coordinate of a point. I think, I hope you have understood this. Right. Now, let us go to the coordinates of origin. You know, in the 2D coordinate geometry, there you have written coordinates of origin as 0, 0. In the 3D also, coordinates of origin as 0, 0, 0, because go to the origin. So from that point to you can't able to draw the perpendicular distances from that point to the x, y, y, z, zx planes. Hence coordinates of that point becomes 0, 0, 0. Remember this point. Next, students, see, by this three mutually perpendicular lines, okay, by this x, y, z axis, this space divides into 8 parts. Am I right? So this is one part, this is one part, here 1, 1, here 1, 2, 3, 4. So in the upside portion, we are getting 4 parts. Okay, see, this is xy plane. So this is zx plane, this is yz plane. So by these 3 planes, okay, one is like this, one more is like this, one more is like this. By these 3 planes, okay, this space divides into 8 parts. So 4 are above this system and 4 are below this system. Okay, so totally this space divides into 8 parts. That 8 parts are said to be octants. In the 2D geometry, there we have divided that plane into 4 parts. We called them as quadrant there. First quadrant, second quadrant, third quadrant, fourth quadrant. Like this here, we divide the space into 8 parts, which should be called them as octants. What we have to say? Octants. Octants. Okay, students. Now, let us know the sign of a point which belongs to this 8 octants. You know, in the 2D geometry, if a point belongs to the first quadrant, so there you got signs of that point says plus comma plus. When it goes to the second quadrant, minus comma plus. In the third quadrant, minus comma minus. In the fourth quadrant, plus comma minus. In the same manner, in the 3D coordinate system also, if you go to this sum, okay, this is the space which is bounded by positive x-axis, positive y-axis, positive z-axis. Hence, if a point belongs to this first octant, which will get plus comma plus sign. No confusion. What is this? Octant 1, first octant, which is bounded by positive x-axis, positive y-axis, positive z-axis. Hence, if a point belongs to this octant, it will get plus comma plus sign. Plus. In the same manner, go to this. It is bounded by negative x-axis, positive y-axis, positive z-axis. Here x is negative, y is positive, z is positive. Minus comma plus. Now go to this in the upside portion. Negative x-axis, negative y-axis, positive z-axis. Hence, if a point belongs to this octant, it will get minus comma plus. In the same manner, go here. This is bounded by positive x-axis, negative y-axis, positive z-axis. So x is positive, y is negative, z is positive. Means plus comma plus. In the same manner, write the signs of a point which belongs to the bottom level octants. So totally, here we have got 8 octants. So if a point belongs to that 8 octants, which follows these signs. So write first 4 pluses, 4 minuses. Next 2 pluses, 2 minuses, 2 pluses, 2 minuses. So plus minus. Like this we will get whose signs in the 3D coordinate geometry. I hope you have got it. So if a point belongs to the x-axis, what will be the coordinates of that point? Same like in the 2D. See, suppose consider this as x-axis, this as y-axis, this as z-axis. If a point belongs to the x-axis, it will get coordinates like this: x comma 0 comma 0. On the x-axis, y coordinate and z coordinate of a point becomes 0. So in the same manner, if a point belongs to the y-axis, 0 comma y comma 0. If a point belongs to the z-axis, 0 comma 0 comma z. Okay students, if a point lying on the x-axis, y coordinate and z coordinate of that point becomes 0. If a point belongs to the y-axis, 0 comma y comma 0. If a point belongs to the z-axis, 0 comma 0 comma z. Okay, right. Next students, see here. Now let us find the perpendicular distance from a point to the x-axis. Okay, one point P is given in the space. Let it be x1 comma y1 comma z1. Now I am asking you to find perpendicular distance from this point to the x-axis. From this point to the x-axis. How do you find? Tell me. What is my question? Perpendicular distance from this point to the x-axis. Means, see, find the projection of this point on x-axis. What is the projection of this point on the x-axis means? See students, you get like this. Let it be q. x1 comma 0 comma 0 you will get. What is this? Projection of this point on x-axis. Now measure this distance. You know, to find the distance between the 2 points in the 2D geometry, you used the square root of x2 minus x1 whole square plus y2 minus y1 whole square. In the 3D geometry also, if you would like to find the distance between any 2 points on the space, like if one point coordinates are given as x1 comma y1 comma z1 and other point coordinates x2 comma y2 comma z2. If the 2 points are given like this in the space, so you people have to use this formula. Same like 2D. So x2 minus x1 whole square plus y2 minus y1 whole square. But in the 3D, z coordinate is getting extra, no? So take the difference of these two. z2 minus z1 whole square, units you have to write. Okay students. So otherwise you can write this one as x1 minus x2, y1 minus y2, z1 minus z2 whole square. No difference will come in the result. Okay, difference of x coordinate whole square, difference of y coordinate whole square, difference of z coordinate whole square. So apply same formula here. This is the point which is given in the space and whose projection on x-axis is x1 comma 0 comma 0. Now get the distance between these two. So how much do you get? x1 minus x1, which becomes 0, and here y1 square plus z1 square units. What is this summa? The perpendicular distance from that point P, which is located in the space to the x-axis. In the same manner, get the distance from this point to the y-axis. Find the distance from this point to the y-axis. So what you have to do? Identify whose projection on y-axis. Let us say that projection as R. So 0 comma y1 comma 0 you will get. This is the projection of P on y-axis. Now get the distance between these two. PR. How much do you get? This part becomes 0. x1 square plus z1 square units you will get. What is this? distance from the point which is given the space to the y-axis. In the same manner, get the distance from this point to the z-axis. So let us identify whose projection be on z-axis. 0, 0, z1 you will get. So how much PS will be? Root of x1 square plus y1 square units. Okay, students. So what did I do here? I calculated the distance from the point to the x-axis, y-axis, z-axis. That point to the xy plane, yz plane, zx plane in the beginning itself I gave you. Perpendicular distance from that point to the xy plane is z. Perpendicular distance from that point to the yz plane is x. Perpendicular distance from that point to the zx plane is y. Like that I defined in the beginning. Now what are these distances from that point to the x-axis, y-axis, z-axis respectively. Okay, and also you have learnt how to find the distance between 2 points in the 3D coordinate geometry, same like 2D formula. Okay, but here one z coordinates extra we are getting, hence the distance between 2 points in this space is square root of x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. Suppose if you would like to find a distance from origin to x comma y comma z, origin to x comma y comma z, can you find? So here 0 comma 0 comma 0, a point P whose coordinates x comma y comma z. How do you find whose distance? OP is equal to square root of difference of x coordinates, x square plus y square plus z square units. This is the distance from origin to a point in the space, as x comma y comma z is root x square plus y square plus z square. You know, students, section formula which you learnt in the 2D coordinate geometry. See, 2 points are given. So let us consider this point coordinates be x1 comma y1 comma z1, and this point coordinates x2 comma y2 comma z2. Now find a point P which belongs to this AB line in the space. Okay, so which is dividing AB in the ratio m is to n. Let us consider coordinates of PB x comma y comma z. Find the coordinates of P which divides AB internally in the ratio m is to n. So because P is inside of AB, no, hence I am saying P is dividing AB internally. So same like 2D formula. So here P coordinates x comma y comma z, which is equal to mx2 plus nx1 by m plus n, comma my2 plus ny1 by m plus n, comma mz2 nz1 by m plus n. I hope you have understood this. Same like 2-dimensional coordinate geometry formula only, but here extra this is z coordinate will come. Okay, students, suppose if P is exactly middle of AB, then m is to n will become 1 is to 1. So put m equal to 1, n equal to 1 in this, so that your P coordinate will become x1 plus x2 by 2. So y1 plus y2 by 2, z1 plus z2 by 2. So this is the midpoint formula. So sometimes this P will be outside of AB. See, A coordinates are given here, x1 comma y1 comma z1. B coordinates are given here, x2 comma y2 comma z2. Extend this. Here somewhere P is there, whose coordinates are x comma y comma z. Now P is dividing AB externally. M is to N. P is dividing AB externally. Here PA by PB, which is equal to M by N. So P is their external portion of AB. Hence, so here you would have to represent that ratio with negative sign. Okay, students? And see, if you would like to find the coordinates of P, you people have to use this formula. mx2 plus minus nx1 by m minus n, comma my2 minus ny1 by m minus n, and mz2 minus nz1 by m minus n. Here m should be positive and n should be positive. Be careful. But for the sake of representation, here we write the ratio with negative sign. But ratio should be always positive, you know that. Okay. So here sometimes you make it like this, -2:3. But while substituting m value, n value here, you have to take m value 2, n value 3. Don't take m value -3. Already here we have kept minus symbol middle, so that while doing the applications, take m as 2, n as 3. Okay. So this is external division formula. Because P is dividing AB externally. Hence it is known as external division formula. Okay, students? Right. Next, let us go to find centroid of a triangle. When the vertices of the triangle are given, same like 2D, but here one extra. Okay, order extra coordinate will come, z coordinate. Okay, see here, 3 triads will be given to you, and they will ask you to find centroid of the triangle formed by this triangle, whose vertices will be given to you. You know, same like 2D. So what will be the formula for centroid? x1 plus x2 plus x3 by 3, comma y1 plus y2 plus y3 by 3, comma z1 plus z2 plus z3 by 3. Okay, students, this is a centroid formula. Next, let us go to find centroid of a tetrahedron. You know, tetrahedron. See, whose base looks like a triangle. Through this AB side, one triangle will go like this. Through this BC also one triangle will go like this. Through this AC also one triangle will go like this. The 3 triangular planes which comes from AB, BC, AC, 3 will be concurrent at this point. This is 3-dimensional figure. This is a triangular plane. You have to draw like this, and this is a triangular plane whose base is BC, like this. And one more triangular plane, AC, here. AB as base, take like this. 3 will meet at this point, let it be D. So, in this figure, how many triangles are there? Total 4 triangles and 4 vertices. Okay, base has 1 triangle and lateral surfaces 3 triangles. And here, above 1 vertex will form. Here base has 3 vertices and top, let it be D, 1 vertex. Total tetrahedron will get 4 vertices, okay, and 4 triangles. Okay, now take any one of that 4 vertices, and opposite to that vertex there will be a triangle. Suppose here D vertex is there. From that D vertex to the what is the opposite triangle of D vertex is missing? This ABC. And here this is one plane, triangular plane. So from this vertex to what is the opposite triangular plane of this B vertex means this will come. In the same manner, this is a triangular plane which is opposite to vertex C. Like that, there we have 4 vertices and 4 triangular planes. And every triangle has centroid. You know that. Okay? Now, draw a line segment from vertex to the opposite to triangle centroid. Connect vertex to the opposite side centroid. That will be called median of the tetrahedron. How do you get median of a tetrahedron? It is a line segment connected by vertex to the centroid of opposite triangle. Like that 4 medians will be possible there. That 4 medians will be concurrent at one point, that is called centroid of tetrahedron, and that centroid divides each median of the tetrahedron in the ratio 3:1, not 2:1. In the 2D geometry, centroid divides each median in the ratio 2:1 now, whereas in the tetrahedron 3:1. Okay? But here what you people have to remember, 4 vertices of the tetrahedron will be given to you and they will ask you to find whose centroid. See, G is equal to x1 plus x2 plus x3 plus x4 by 4. So y1 plus y2 plus y3 plus y4 by 4. Z1 plus Z2 plus Z3 plus Z4 by 4. This is the centroid formula for tetrahedron. And here you would have to learn one more point, Amma. So 3 points will be given to you and they will ask you to find whether those 3 points are collinear or not. How do you say? 3 points are given, like A, whose coordinates x1, y1, z1, and B coordinates x2, y2, z2, and C coordinates x3, y3, z3. Whether these 3 points are collinear or not. How do you say? Same like in the 2D. How did you check? Tell me, students. You use it to measure distance between A, B, B, C, C, A. 3 distances you will get. Okay? If sum of any 2 distances is equal to third distance, then you said there that 3 points are collinear. In the same manner, here you can check. Measure the length AB, BC, CA. Among that 3, if sum of any 2 is equal to the third one, hence that 3 points are collinear. Otherwise, so check like this. Okay, Z x1 minus x2 by x1 minus x3. y1 minus y2, y1 minus y3. Now z1 minus z2 and z1 minus z3. So if you find these 3 ratios are equal, then you can call them as collinear points. Okay, students? I hope you have understood this. Now let us go to one more point. You know, in the section formula, you got that formula. So sometimes they will ask you this question. At what ratio xy plane divides line joining of the AB? A coordinates x1, y1, z1, B coordinates x2, y2, z2 will be given. And at what ratio xy plane divides AB? XY plane divides AB. You know, on the XY plane, y coordinate of every point is 0. On the xy plane, what is 0? Y coordinate of every point is 0. Hence, in the section formula, equate mz2 plus nz1 by m plus n, which is equal to 0, and simplify this. So after simplification, you will get m by n. So send it to the right side and simplify this. You will get minus z1 by z2. You can also write it as minus z1 is to z2. What is my question? There is a one line segment whose endpoints are given. A coordinates x1, y1, z1, B coordinates x2, y2, z2. At what ratio xy plane divides line joining of AB? Means on the xy plane, as we people know that z coordinate of every point is 0. Hence I have equated z coordinates. So I got this ratio as minus z1 is to z2. In the same manner, at what ratio yz plane divides this line joining of AB? On the yz plane, x coordinate of every point is equal to 0. We get that x coordinate in the section formula, so that you will get m by n is equal to minus x1 by x2, which is nothing but minus x1 is to x2. At what ratio yz plane divides line joining of AB means what you have to say? Minus x1 is to x2. Okay, students? In the same manner, at what ratio zx plane divides line joining of AB? On the zx plane, as you know, y coordinate of every point is equal to 0. So that on equating y coordinate in the section formula, so you will get m by n is equal to minus y1 by y2, which is equal to minus y1 is to y2. Okay? I hope you have understood these conceptual points from this 3D coordinate geometry. And in this 3D coordinate geometry, two more subtopics objectives are left, which are called direction cosines and direction ratios of a straight line. Now let us discuss the direction cosines of a straight line. You know, student, see, for example, see, consider the 3D system like this. This is origin and x, y, z. See, I would like to draw here. I am taking a line through this 3D. Okay, I have taken a line, rough diagram. Okay, see, if you want to extend this z-axis, you can. See, let us take this one is the angle made by this line with x-axis. This is the angle made. This is the angle made by this line with y-axis. So let it be gamma. This is the angle made by this line with z-axis. What are alpha comma beta comma gamma? Angles made by that line with x, y, z axis respectively. Okay. So if you define cosine ratio with respect to this angles, three angles, alpha, beta, gamma. So you get like this: cos alpha, cos beta, cos gamma. So these are said to be direction cosines of this line. So generally we denote this direction cosines of that line as L comma M comma N. So what are direction cosines of this line? Cos alpha, cos beta, cos gamma, where alpha comma beta comma gamma are the angles made by line with xyz axis respectively. So in one direction. In other direction, if it is alpha, this will be 180 minus alpha. This will be 180 minus gamma. This will be 180 minus beta. If you define cosine ratios with respect to this 3, you will get cos of 180 minus alpha, cos of 180 minus beta, cos of 180 minus gamma. So what do you get? Cos of 180 minus alpha, which becomes minus cos alpha, minus cos beta, minus cos gamma. Even these are also called direction cosines of this line. If you treat L comma M comma N are direction cosines of this line, even minus L, minus M, minus N are also direction cosines of this line. Okay, suppose if the direction cosines of a line, you may get like this, 3 comma minus 2 comma 1, and if you multiply these three with minus 3 plus 2 minus 1 also direction cosines of same line. See, observe here, cos alpha, cos beta, cos gamma. When you multiply all this with minus sign, you have got a direction cosines of same line, no? Hence, if direction cosines of a line given like this, if you multiply these three with minus, so you will get other triad. So even that represents direction cosines of same line. I hope you have understood the meaning of direction cosines of a straight line. Okay, alpha comma beta comma gamma are the angles made by a line with x, y, z axis respectively. Then cos alpha, cos beta, cos gamma, okay, is known as direction cosines of that line. Even minus cos alpha, minus cos beta, minus cos gamma are also direction cosines of that same line. Now, see students, suppose, see, this is origin, this is x-axis, this is y-axis, this is z-axis. Take a point in the space px comma y comma z, which is r units away from origin. Now alpha is the angle made by this OP with x-axis. Now drop a projection on x-axis, whose coordinates x comma 0 comma 0. So this length is how much? X. Now define cos alpha. What is cos alpha? So in the direction cosines, x coordinate. So define cos alpha. X by r you will get. Now x equal to r cos alpha. So what did I do? I took a point in the space and I have drawn a projection P on x-axis. I got x comma 0 comma 0. So this length is x-axis. So OP is a one line. Okay. So this is making alpha angle with x-axis in the positive direction of x-axis. Now I have defined cos alpha because here one right angle triangle is formed. I defined cos alpha. I got x by r. Now x equal to r cos alpha. In the same manner, so drop whose projection on y-axis and define cos beta. Beta is the angle made by that OP with y-axis. So you get cos beta as y by r. So y equal to r cos beta you will get. Now in the same manner, drop whose projection on z-axis and gamma is the angle formed by OP with z-axis. Define cos gamma. You will get z by r. Now z is equal to r cos gamma. Okay students. Now measure the distance from O to P. You get x square plus y square plus z square. Now OP we have taken as r. root of x square plus y square plus z square. Now square on both sides. R square is equal to x square plus y square plus z square. Okay, students? Right. Now, see here. X value. R cos alpha, R cos beta, R cos gamma you got. Substitute in this. So that you will get R square is equal to x square. X square means R square cos square alpha plus R square cos square beta, R square cos square gamma. Now take R square common and cancel with left side, so that you will get 1 is equal to cos square alpha plus cos square beta plus cos square gamma. Now 1 is equal to L square plus M square plus N square. This is very, very important. So remember, like a standard result. L comma M comma N are the direction cosines of a straight line. If you find the sum of the squares of the direction cosines, whose result will become 1. And here you have to remember one more point. Suppose you know 1 cos square alpha can be written as 1 minus sin square alpha. So this is also 1 minus sin square beta. This is 1 minus sin square gamma. 1 cancel. Now bring these three to the left side, so that you will get sin square alpha plus sin square beta plus sin square gamma, which is equal to 2. Remember this relation also. Okay, students, and here you have to remember few more points related to this direction cosines and direction ratios. Now let us learn the meaning of direction ratios. Till now we have discussed the meaning of direction cosines. No? Now let us learn the meaning of direction ratios, DRs, of a straight line. Direction ratios means, see, the proportionate values of direction cosines of a straight line are known as direction ratios. What are L comma M comma N? Direction cosines of a straight line, and whose proportionate values like A comma B comma C. So which are proportional to this, means if you find L by A, M by B, N by C, you get same ratio. So these are said to be DRs of a straight line. DRs of a straight line. So these are DCs of a straight line. Straight line. So if you take the ratio of corresponding coordinates, you get the same ratio. The proportionate values of direction cosines of a straight line is said to be direction ratios. The direction ratios of a straight line not unique, because okay, for this DCs you will get many more proportional values. Okay, students. Hence, direction ratios of a straight line not unique, but direction cosines are okay. Two pairs of direction cosines are two triads of direction cosines are possible, but whereas for the direction ratios you get many more, not unique. See, I hope you have understood. See here, suppose 2 comma 4 comma 6. So you may get 4, 8 to 12. If DCs of a line are given, then these will be called DRs, because if you take the ratio 2 by 4, like 4 by 8, like 6 by 12, you get same ratio. Hence these will be direction ratios of a line which contains 2 comma 4 comma 6 as direction cosines. So like that you can draw many more whose ratio is 1 by 2. Whose ratio is 1 by 2. Okay, like many more proportional values you can write. See here, for example, take a ratio as 1 by 3, like multiply all of them with 3, 6, 12, 18. These are also direction ratios of this. Like many more you will get. And see here, there is a one line. On the line, 2 points are given. A coordinates x1 comma y1 comma z1, b coordinates x2 comma y2 comma z2. Now find the DRs of AB. DRs of AB. Very easy, students. When the 2 points on the line are given, just take the difference of respective coordinates of AB, like x2 minus x1, y2 minus y1, z2 minus z1. So these are the DRs of AB when 2 points on the line are given. Otherwise you can write x1 minus x2, y1 minus y2, z1 minus z2. Even that result will be also DRs of AB. However, you can take the difference of x coordinate, y coordinate, z coordinate of AB. Okay? I hope you have understood how to find DRs of AB. And to find DCs of AB, you would have to define this difference with R. R means distance between AB. Now prepare R aside. You know how to find distance between AB. Difference of x coordinate whole square and difference of y coordinate whole square and difference of z coordinate whole square. Use this formula and get the distance between AB and divide that result R with these three, so that you will get direction cosines of that line. Whenever the 2 points on the line are given, this is the way to find direction ratios of that line and the direction cosines of that line. I think this is very easy. Okay, if you take the difference, you will get direction ratios. If you divide this direction ratios with R, you will get direction cosines. Sometimes direction ratios of a line will be given to you like ABC, and they will ask you to find direction cosines. DRs of a line or A comma B comma C. Then find whose DCs. Now get R value. R value in this case directly you have to take A square plus B square plus C square. Now divide these three with this result, so that you will get direction cosines. These are DCs of the same line. B by root A square plus B square plus C square. C by root A square plus B square plus C square. Okay, students, when the DRs of the line are given, and apply this formula, so that you will get DCs of the same line. Okay, right. Next, students, what are the direction cosines of x-axis? When you draw a line on the x-axis, angle between the line and x-axis is 0. So then alpha is 0 and beta and gamma equal to 90 degrees you will get. Then DCs of x-axis, what do you get? Cos 0, which becomes 1, and cos 90 which becomes 0 comma 0. In the same manner, DCs of y-axis, can you expect what do you get? Tell me. So 0 comma 1 comma 0 you will get. Now DCs of z-axis, what do you get? 0 comma 0 comma 1. Remember this point also. See, students, so hereafter you would have to find angle between the two lines when whose direction cosines are given. There are two lines and whose DCs are given like this, L1 comma M1 comma N1 and L2 comma M2 comma N2, whose direction cosines are given and asking us to find angle between them. So use this formula, cos theta is equal to mod of L1 L2 plus M1 M2 plus N1 N2. If you apply this formula, you will get angle between the two lines. If theta is 90, means if the two lines are perpendicular, cos 90 value 0. Hence L1 L2 plus M1 M2 plus N1 N2, which is equal to 0, you will get. This is the cos theta formula. So suppose if you want to find sin theta, you can apply this formula. Sin theta is equal to square root of L1 M2 minus L2 M1 whole square plus M1 N2 minus M2 N1 whole square, and here N1 L2 N2 L1 whole square. If you apply this formula, you will get sine angle between the two lines. If you want cos theta, use this formula. If you want to sin theta, use this formula. Suppose sometimes they will ask you tan theta also. In such case, you have to divide this by this. Suppose if you want to tan theta, what do? Tan theta. So tan theta can be written as sin theta by cos theta. Now sin theta means this one you can express with summation notation. Summation of L1 M2 minus L2 M1 whole square by mod of L1 L2 plus M1 M2 plus N1 N2. So that you will get acute angle. So in the options sometimes they may not give you acute angle. So when the acute angle is given, how to find obtuse angle, you know. Whenever the two lines intersect like this, one is acute angle and one more is obtuse angle. So if it is 30 degrees, this will be 180 minus 30, which becomes 150. If it is 45, this will be 135. Okay, if you use your modular symbol, you will get acute angle. So in the options, sometimes they may not give you acute angle, they may give you obtuse angle. So 180 minus theta you have to do. So this is the tan theta. Okay. So where theta is the angle between the two lines, whenever their DCs are given, this is the way to find cos theta, sin theta, tan theta. And here sometimes only DRs of the line will be given to you and they will ask you to find angle between them. Now A1 comma B1 comma C1 and A2 comma B2 comma C2. These are the DRs of two lines and find the angle between them. So same, when the DRs are given, how to find DCs I said to you na. Now get whose DCs and apply the previous formulas. When DRs of the line are given, how to find DCs you know. How to find DCs of this line you know. Then apply the cos theta, which you learnt as mod of L1 L2 plus M1 M2 plus N1 N2. Otherwise, so use this direct formula, cos theta, which is equal to mod of A1 A2 plus B1 B2 plus C1 C2 whole by root of A1 square plus B1 square plus C1 square into root of A2 square plus B2 square plus C2 square. Use this formula so that you will get angle between the two lines whenever their R's are given. Okay students, right? Next, okay, two more points which you have to remember from this chapter, that is angle between the two diagonals of a cube. So proof for this question, you can go through my channel. So I taught to you this proof also, angle between the diagonals of a cube. So you get cos inverse of 1 by 3. See, you know, cube. In a cube, there are 4 diagonals, same like our classroom. In a cube, you can draw 4 diagonals. Okay, students. See, suppose if you take this is O, A, okay, C, B, this is C, okay, and D, E, F, okay, I, you can take it as G. So this is cube. In this cube, OG, okay, and AE and BF and CD. 4 diagonals are possible, same like our classroom. That corner to this corner to that corner, and this corner to that corner, and that corner to this corner. If you treat our classroom as a cube, you will get 4 diagonals. If you find angle between any two diagonals of this cube, you will get theta is equal to cos inverse of 1 by 3. Okay, this is very, very important. Remember, like a standard result. So for the proof for this question, you can go through my channel. So you will get this proof from the class. And next year you would have to remember one more point. So here parallelepiped will be given to you, same like cuboid, but whose surfaces looks like parallelograms. So this is a parallelepiped. Parallelepiped, like cuboid. So cuboid surfaces looks like a rectangle, but parallelepiped surfaces looks like parallelograms, whose co-terminal edges lengths will be given to you. This is A and this is B, this is C. So lengths of co-terminal edges of a parallelepiped are given as ABC, and then find the angle between any two diagonals of this parallelepiped. So this is the formula. Cos inverse of plus or minus A square plus or minus B square plus or minus C square by A square plus B square plus C square. Use this formula so that you will get angle between any two diagonals of a parallelepiped. So this is the complete concept of 3D coordinate system and direction cosines and direction ratios of a line. I hope you have understood this concept. So I am requesting you to go through your exercise questions so that you will get more clarity from this chapter. So while doing the problems, if you get any doubts, you can contact with me through my WhatsApp number. So in every video I am posting my phone numbers over there. So you can contact with me through the WhatsApp if you have any doubts. And also I am requesting you to subscribe and like and share my channel so that my classes reaches to many students. Thank you students. Thank you one and all.